Hey everyone, this is the last of 3 examples that I'm posting here about completing the square method. And in all of these, a is equal to 1, so we don't have to divide every term by some number before we start. So we're okay on the first step on all of these. But this time, half of b is not going to be a whole number because b is odd. So it creates fractions that you deal with, but I'll go through them slow, and fractions should not be particularly hard for you. You got to not fear them. So anyway, x squared minus 5x already on the left side with the constant already on the right side. So I do my setup. X squared minus 5x plus blank to complete the square equals on the right -4 plus blank to balance the equation. Okay, so again, what gets added here has to be added there. So I'm going to take half of b, and b is -5. So all I do when it's an odd number, to divide it by 2 is just put a 2 under it, show it divided by 2. It happens to equal 2.5, but just write it in this form, rational form is fine. So I'm creating my factor, x minus 5/2 quantity squared. I want this trinomial to be whatever this is when I multiply it together. So when I square -5/2, it's like I'm squaring the -5, oops, and I'm squaring the 2. So I get 25 in the numerator over 4 in the denominator. -5 squared is 25, 2 squared is 4. So that is 25/4 that's going to go in here. Okay, and where it really matters is over here, because it has to be added to the -4. So I've added on both sides to complete the square. This was what I was going for, and this is what I care about. So that's going to allow me to use the square root method once I add these two numbers together. So when I'm adding a whole number and a fraction, I want to rewrite the whole number in the same denominator as the fraction so I can combine them with common denominators. So 4, how many fourths is 4? So if I think about literally just taking this back to, middle school, if I have 4 pizzas and each one is cut into fourths, how many fourths is the same as 4 whole pizzas? Well, there's 4 in each. So 4 pizzas times 4 fourths in each is 16 fourths. Okay, so I'm going to convert this -4 right here to be -16 fourths. Okay, and now I can combine it with the positive 25 fourths. So 25 minus 16 is a positive 9. So I'm going to have 9 fourths as 25 fourths and a -16 fourths. I'm going to end up with positive 9 fourths. Okay, so now I'm going to take the positive and negative square root of both sides. So on the left side, this squared, the square root is just that factor, x minus 5/2, equals on the right side, positive and negative square root of 9 fourths. Okay, kind of thankfully, 9 and 4 are both perfect squares. This is equivalent to, because I can break a fraction apart or put them together under a radical, it's equivalent to the square root of 9 over the square root of 4. Square root of 9 is a positive 3. Square root of 4 is a 2. So I have 3/2. So this is going to be plus or minus 3/2. And then if I want to get this x alone, I'm going to add that 5/2 in front of the plus minus. So plus 5/2 plus 5/2. I will have a 5/2 on the right side, and I will leave my x alone on the left. So I went plus 5/2 to get rid of that, plus 5/2. So it's here. Okay, and this 3/2 is the square root of the 9 fourths. So now there's a plus path and a minus path. I have 5/2 plus 3/2. That's the plus path, and then the minus, because there's always 2 solutions to a quadratic equation, 5/2 minus 3/2. So 5 halves plus 3 halves is 8 halves, which is 4. 5 halves minus 3 halves is 2 halves, which is 1. So my solutions are 4 and 1. Okay, when they're whole numbers, they're rational numbers, there's no radicals, it means that this could have been factored. I could have moved that 4 over and factored it. It would have factored quite easily to x minus 4 times x minus 1. But when you have a choice, that's what you will want to do. But when you don't have a choice, you do have to learn this method. And this is a good practice problem to work with, a couple complexities being an odd number here that creates a fraction, but basically not too bad. So that's it for completing the square method. Come get help from me if you're having trouble on some of these. Thank you.